Hello, hi everyone. So today we are going to discuss about data engineering, why it's today's need, and what are skills that been required to be a data engineer. We'll just discuss the overview of Python and SQL and why they are needed. We'll just have a brief view of what data is and different type of a data, where they can store, how a data pipeline is created, and we're going to discuss big data. Then we'll cover a PySpark and Databricks. So and with the industry use case that we normally face. Then I'll show you how to do an end-to-end pipeline in Azure. Maybe the pipeline can be in any cloud, but typically in the cloud the terminologies change, but the underlying architecture or the technology remains same, and the upcoming program detail. So let's start with data engineering. So what is a data engineer? And we often get confused with data engineer, data scientist, business analyst, BI analyst. So these are the major terms that we often face when we will be applying for a job interview. Uh, I'll try to cater all those questions, and maybe you can go for a right job once you understand what is. But data engineering is something which covers everything, and it's a base for data scientists and data analysts. We'll understand what is data management, different layer, provenance, what is a distributed computing, designing a data pipeline, and then data engineering jobs and required skills. All right. So what is a data engineer? So data engineer is an act of collecting data, transforming it, and validating it. So in other words, you can easily say how to make data more consumable or understandable. For example, if I give you 1,000 rows of data and it has many columns, now we are the one who is going to model the data uh, to get the insights from it and to make the data more understandable. So usually when we get the data from the source, it is more of a raw data, which is uncleaned, and sometimes it doesn't have any schema. We try to structure the data and getting the data from various sources, transforming it, that is cleaning and converting from one form to another, and then validating the data so that we don't miss out any records. So even while transformation, we would try to make sure that our data is end-to-end correct. Let's come to different roles and where we stand. So when we have a data, so the first person who is going to look at the data and who will bring out the data from the source to the raw layer. Raw means the data, whatever data produced from the source should be exactly same as in the destination. That's called a raw layer. Then we come to a silver layer, uh, or we can say, and the raw layer is also known as bronze layer. Then we come to silver layer where we clean up the data and put it into another layer. It's just we read from a raw layer, we transform it, we convert it, make it more understandable, and then store it to a silver layer. And then comes the gold layer, wherein you create facts and dimensions. Will come later on in the course. I'll explain you what are the facts and dimensions. We try to model the data, and once somebody comes, so usually when a business person comes, he won't be able to understand the data because he just wanted to see a chart, pie chart, or a data which speaks in the form of uh, images. That's the something business will understand. If I give him 1,000 rows and see this is your data, then nobody will understand, not just the business, we also. The work of AI and ML engineer comes once you transform the data, put into a final serving layer. It could be a data lake. It could be, I'm talking about that gold layer. Uh, it could be a SQL database as Cosmos DB. Then the AI and ML engineer will read the data, and then they will do predictions or put ML model on it and create the ML machine learning model and do the prediction on top of it. And then comes the work of AI and ML are the same part. So, so from the scratch to making the data more clean will be the part of a data engineer. And after that, either it will go to a reporting layer where business will see, or it will go to ML or AI engineers where they are going to do predictions and get more insights from, derive more insights from the data. Then comes the BI developer. So BI developer, that is business intelligence. So the BI developer has a two part. One is to, so once a BI developers is the one who understand the business, tries to model the data, as well as who creates the overall the Power BI report. Or any sort of a report, they are the one who can create a view of the data. Then comes the data analyst. So now data analysts are similar to the role will come similar to when the work of data engineer is done, and they will be the middle layer between the data engineer and a business person. So a data analyst is plays more around with on the computer data, which is transformed data, and will try to they also try to do the machine learning or try to do to get more insights from the data, and ultimately whatever insights they develop, let's say they develop a new KPI, that is business indicator, saying that we want the data from, we don't need the data from past 10 years, and we want the data from past 5 years only. So then they will inform the data engineers, and then data engineers will come again and do those work. There is a database administrator whose job is very confined to a database level, wherein it manages all the servers and database, and in case a new source or a new user is onboarded, the database admin is the one who is going to provision a new source or a user. Then comes a report developer. So the person who develops, who reads the transformed data and develops a view, pie chart, line chart, or histogram on top of it. There comes the report developer. Data developer are the one who, it's a similar part, it's similar to the data engineer, wherein they will get the use cases from the business. So let's say they got the 10 KPIs to develop, and they are the one who are going to develop several reports on top of it. Not reports, the data that will be the source for reporting it. That data will be generated by data developers. Data architects are the one who will create the overall data pipeline, data structures, or they are the one who will, from the source till the ML and everything, they are going to design the overall architect of a company. For a person to be a data architect, he has to know from the scratch to the ML every knowledge. Then a person can become a data architect. Then data integration specialist. So to get the data from one source to put it another source, there will be some data integration tool, and the people who work on that will be the data integration specialists. And of course, ETL developer. ETL developers are the one who works on the data extraction, transformation, and load. So ETL developer it will be just the people who will get the data uh, and load it to somewhere and just clean up the high level. But the data engineer are the one who actually covers most of the part here. They can be so once a person is a data engineer, we expect them to know database admin work. They can design the database. They know how to. This is very important. Data developer and an ETL one. So if you search for any job, definitely you will see that they would be needing some sort of a data transformation tool. For example, they will go for a Spark based or SQL based, or and then you will see if the person knows any ETL tool, that is an add-on from him. So let's move on to the next part. It's the same thing. How data scientists will be able to take the data science project from end to end, and they can help store large amount of our data and create predictive model processes and present their findings. And data engineers are the versatile generalists who uses computer science to help process large data set, and they typically focus on coding, cleaning up the data set and implementing the request that comes from data scientists or data analysts or business. Then comes the data analysts. They are typically the people who come from the company and understand the specific queries from the chart. So they are the person, you can say, the person between the business and the data engineers. Let's understand. This is a typical model for every data layer. How the data life cycle goes. So there can be many data sources. It can be SAP from web, can be SQL database, Oracle. From that we get the data, or the data source can be even your phone. Your phone can generate a data, and it goes to some sort of a database, and from the database we can fetch the data. So in today's world, as we know, data is the everything, and every 2 years the amount of data that we generate becomes double. So the work of a data engineer definitely is going to increase in future, and it will be staying for a long time. And it's not that the job of a data engineer was not from the beginning. From early 2000 or 2019, even when the SQL started, people used to do those things because initially also companies generates their data, people generate the data, they need the people who can derive that insight. But now in today's scenario, we call them a data engineers because we expect them to know to handle the each type of a data, create a pipeline, and to understand, to handle even if you get a different type of a data. Then comes a data processing engine. So when it comes to big data, Spark is the preferred one, and Databricks is a company developed by Spark itself, and it's the most popular tool which is used by most of the companies. Databricks is as a company, they serve their own Databricks portal, and they have collaborated as a first party service with Azure and AWS. And now the Databricks is also available in GCP cloud. So all the major clouds have Databricks, and it's a widely used tool, and we'll see why it's the why Databricks is one which is used widely, and and how Databricks can give you the capability of the data warehousing as well as data lake. Then when we process the data, we'll store the data into a storage layer. It could be a database Cosmos DB, and then comes our visualization layer. It could be Power BI, Grafana, or uh, ClickView. So there are many data visualization tools. The one which is most popular is Power BI, which is used in several organizations. Next comes the data quality service. So once we know our data, we try to explore our data. We try to correct and clean the data that we get from it. Then comes the knowledge management, wherein we build and maintain the knowledge base of ways to clean and correct our data. Deduplication, so that we don't have the duplicate data, and then we create a correction and standardization method, so that whenever we get the data from different sources, we try to merge them into one source, and we don't um, corrupt our data. Then comes the master data management. So in a company, there are several sources where and uh, uh, every source generates a different type of a data. For example, let's consider Amazon. They can have their own warehousing data, they can have their design engineering data, purchasing data, supplier data, project management. They have the user accounts data, human resources data, and there can be many types of a data. There are several databases in a company, and master data is a one which can connect with all of them. So for example, once you place an order, so I want to know, there will be an order ID and the uh, uh, and the item which we have purchased, the item ID. Then there will be separate database for an item ID, saying that, okay, this is the item ID, this is that price, these are its features, and these are its review. Then there will be uh, where whenever we place an order, there will be a transactional system which will have all the transaction related queries. So for example, user first ordered something, then he has cancelled it, and then he reordered something. So that information of uh, whatever user have purchased or he has placed COD, that goes into one system that is called master data. So master data is the one with which we, of course, not every data can be connected, but we try to generalize. So if I see my master data, uh, so usually whenever a company tries to generate MDM project, in short we call MDM, master data management. So it's a very typical task which is done by a data engineer. So, and because what happens in some cases, you have, uh, let's say this is an item X, and in another database it is called X and Y. How do you connect that two database? Because that database has a different ID, this has a different data ID. So that mapping you need. So definitely a master data management is something a stakeholder, business holder needs. Then a data provenance, wherein uh, uh, once you get a data, it converts into one form to another, and then we generate our report. Uh, let's come to the same thing, data wrangling, where we extract our data. put it into a staging layer, transform and load into data warehouse, and then we do analytics on top of it. And this is something which is used by every company, wherein they get the data from different sources and they load it to a data warehouse or data lake, and then we try to do analytics on top of it. All right, let's come to distributed system. So when it comes to why distributed computing system is becoming so popular, initially it was developed, one was the paper published by Google, GFS, Google File System. Later on it converted into Hadoop file system, which was to calculate the number of words in a book. And the Google based system was that paper, what it did. So it proposed, instead of calculating one machine to have all the burden, what we try to do, we try to distribute our job into multiple machines. Now, let's say if I have a 10 machines and I'll give if one machine takes 10 minutes, then if I take 10 machines, then I would and all 10 machines runs parallelly, I would expect them to finish in 1 minute. So this is the power of distributing system. Of course, not all data you should, it depends on our data. Only if we have a huge data, semi-structured data, we'll go for that kind of. So we'll come on to the part where based on our data, we'll decide what system we want. But in a simpler word, distributed system means calculation on multiple machine and then giving out the result or to the master node. So the slave machines are the one who compute everything, and the master are the one who will know that of course this job is completed. And Spark is one of the prominent example for distributed computing machine. So what we have is, and those machines are called one cluster, which have many nodes. All the computation are done parallelly. It's a scalable. So how is it? So there are two types of scaling that we see in market. One is horizontal scaling and another is vertical scaling. Vertical scaling means we just, so usually what in our legacy system, what used to happen. So we have, let's say, 10 GB RAM, and once our data increases, we'll just change it to 20 GB RAM and maybe 30 GB RAM. But our data is so huge, we process petabyte and terabytes of our data. Getting a 1 TB, 2 TB RAM will be a huge burden. And then we tried, RAM is very much costly when it comes to hard disk. So if you go in a market, you can easily buy a 4 TB hard disk in 4,000 rupees. But if you try to get a 4 TB RAM, it will definitely cost you very much higher. So RAM is a very costly system, and bumping up our system is not a solution. So, and the another way is to do is a horizontal scaling. So today I have a 10 GB one machine. I'll add another machine which will be of 10 GB. Easily I can get 20 GB. Similarly, I can add multiple machine anytime I want. And these machines are usually we call them commodity hardware, and the reason is they are not premium hardwares. So, and those machines can easily fail. Not so if I have, let's say if I have 100 machine, easily I can say 10 machine can fail. But when in a distributed system, we try to So whenever any machine fail, our job should not stop. So if even in a Spark-based system or Hadoop-based system, or in a data warehouse itself, in Azure SQL data warehouse, if one machine stop working, our data doesn't stop, processing does not stop. It will use rest of the machine and start working on it. And once we attach a new machine, it can leverage that machine. So this feature is called as high fault tolerance. That is, a machine is highly available even if the one machine or two machine is lost, our processing is not stopped. Coming on to the data pipeline, so there are several type of sources that can generate our data. That is streaming. We have streaming data, that means a real-time data. Then we have databases and file-based system. It can be SQL or a flat CSV or TSV or TXT file. And application data could be a log data. Then we have an integration tool which can get this data, put it into a data lake, data warehouse, or data lake house, and then you'll provision it, transform it, and serve it to a business or data science or self-serve analytics. So self-serve analytics means you create a data model and then you can connect the data model from Power BI or Excel and do your own analytics on top of it. All right. So typically, when we get the data, we follow two models. Either we extract, transform, or load, or we uh, extract, then load, and then transform. So when we do ETL and when we do ELT, so whenever the data size is small, and we can see that, of course, my data size is small, and I can process on the fly and then store it. That's called ETL, getting the data, transforming it on the fly, and then storing into a database. So in a case where we have huge terabyte of our data, and in that case, what we do, we first load our data and then we transform it. So usually it depends on our data whether to choose ELT, size of our data as well as type of our data, whether to choose ETL or ELT. So we have two types of database that we in a system. Either a data, we have, let's talk about data first. Typically, we will have three types of data. One will be structured data, second one will be semi-structured data, and third one will be unstructured data. Structured data means they have schema. That means you can represent, the data is in the form of tables. Then comes the unstructured data. For example, images, videos. This type of a data are called unstructured data. So our structured data will always go to SQL or a relational type of a database, or our unstructured data will be going to a data lake. And a data lake, and the third type of a data is called semi-structured database, wherein we have a data in the form of key value pair or a JSON. How to imagine in which scenario we will have a key value data? Let's think of a shopping website where I have two products. One is TV and another one is mobile phone. Now I want to create a table from it. So a TV can have different attributes. For example, its power, we can say a power, display, even a mobile has a display, then a phone doesn't have a remote. So what will happen if you put that into a relational database? Wherever the feature of TV will come, mobile feature will and in the same entry mobile, we have to put a null on that, and wherever the mobile attributes will come, and that TV data will we have to put out null. So what we try to develop is a data in a form of key value pair. Let's say TV properties, and then we'll say that these are the properties. And similarly for mobile and mobile properties, and these are its properties. So in that case, and it's not just TV and mobile. A shopping website, e-commerce website has several types of products, and each product has different attributes. In that case, definitely we would need a NoSQL or a semi-structured data, or in a data in a form of a JSON or a key value pair. That data goes into a NoSQL database. That NoSQL means not only SQL. It can store a structured data, but of course it can store a data in form of key value pair, document, or a graph type database. We'll discuss what all this data, and we'll work on this data in future videos. All right. Let's come to data warehouse and data lake. So data warehouse is typically based on structured data. Wherever you have a structured large data, you will go for a data warehouse. If data lake is for unstructured, semi-structured, and structured, all type of data will go with a data lake. And data hub is structured data for data portability. Now, usually in a data warehouse, we put transactional data or a data where a revenue-based data we put in a data warehouse. In data lake, we put all type of a data. It can consume all type of a data, and we try to do machine learning or AI or data science stuff on top of it. Data hub is a place where you can put your data and focus on data integrity and speed for sharing. So you have a hub of data where anybody can connect and get out the data. Choosing a right technology. So as I said, when you have a structured data, you will go for a relational database. And in the market, the famous ones are Oracle database, MySQL, Azure SQL, Teradata, Amazon RDS, PostgreSQL. Data integration tool, wherein, for example, you want to bring out the data, transform it, and store into somewhere, and the person who does it, I'll show you a demo on Azure Data Factory. Then NoSQL database, where you try to put key value or JSON data, or we can say semi-structured data. And a big data ecosystem. This is just an image we took for a big data system, where it consumes all type of data, stores all type of data, and then process it. So we are also going to discuss a SQL overview, and the next part when we'll discuss more on SQL and Python. So today we're just going to discuss what is SQL. That is, it's a structured query language and the standard for relational database system, that is RDBMS. And Python is a very popular programming language, not just for the ease of use. It is widely used by data engineers, data scientists, and it comes with tons of library. Anything that you want to do, you can do it with Python. So if you are data engineer, Python and SQL are the most important skill, or let's say it's a pre-requirement for a data engineer to know. It's not that you have to be a good in programming, but of course in SQL you have to be very good. If you know SQL, you can do anything. You can stand out, create a difference, in your company. SQL is very important, and Python is something which will wrap SQL in it and will work around it. But Python is also a must skill to have. Okay. Uh, let's discuss one of the, let's come on to the demo where I'm going to get the data from HTTP source and on-premise SQL. And I'll use Data Factory to get the data and put it on Data Lake. And then we have Azure Databricks for transformation and to store into a table. And then either send out the data, we can send out the data to SQL DB, or we can directly fetch it from Power BI. All right, let's move on to this demo. All right, so this is a data factory, or let's say data pipeline that we have. Uh, Here I have created copy. We'll come on, so how to create this data pipelining and how to create link services and data sets will come in the future lecture, but it's just to show you how a data pipeline looks. So what I'm doing here, this is, we have an HTTP source where we are getting fire department data set. One source is an HTTP, it's a web-based where you just click on it and get the data. And the second one is a simple SQL database where I'm getting the data from. So if I want, I can view a data for you. Once I get this data, I'll push the data to Azure Data Lake. Uh, and Azure Data Lake is a storage, and we'll come to understand what is Azure Data Lake and what is Azure Blob later chapter. But now, for now, you can just think different type of data. So it's uh, it's a storage service provided by Azure, which is typically for big data processing. And I'm storing that into a demo data lake container, and within that I have this input data folder. I'm getting the data from two sources, one is SQL and HTTP, and putting it out to here. Once this task is completed, the another task is to run a Databricks job, wherein it spin ups, it will call this Databricks to get, uh, it will go to Databricks
Hi, Vikas, your voice is breaking right now.
Databricks cluster, and I have created one cluster here with a single node. And is it fine now?
Hi, Vikas, your
Uh,
voice is breaking basically.
Let me see. Okay, is it fine now?
Yeah, right now it's fine.
Hello.
Yes, now it's fine. Vikas, rather than to showing the how this process is working, just to show the technologies like what you are using it, uh, the two source input, right, where you are getting a data and then storing it and then transforming it, right? Vikas, like you are on mute. Can you unmute? Vikas, can you hear me? Oh, I think he.
Hello. Oh,
Yeah,
sorry, I
yeah.
was on
Sorry.
mute. Oh.
Yeah, what I'm saying, like you can show like
All right.
what technology you are using rather
So I
than to
was.
like explain everything.
Okay. So once we get the data into a data lake, what we do, we have in ADF we have this job. What it does, it triggers a Databricks job. Within that, I have set the configuration of my Databricks from which Databricks cluster it is linked, and then in the notebook path, I have said that this is the notebook that needs to be called. And within that notebook, I have written several queries. First one is to connection to my data lake, where I have set out this data lake Gen2 account, my container name, and my input folder. I have mounted to this location. Don't get confused with the commands. It's a very simple commands. So once we try to develop it, we will be easily be able to do it. It's and then we'll come to I'll explain you how to write this command. It's very simple. So what I do, I read a data from a SQL source, write it to a CSV file. If I open it and see, you can see a delimited text file. And then once the data is loaded to my data lake, the next job, my database triggers, and from here I'll read that CSV file. I'll get some insights from it. I'll transform my data. Uh, Here I have put out the schema for it, transform the data, and then store it to a table that is save as to one to a Parquet file, and I just shared into a Delta table. So this is a very interesting thing how our Databricks has now become a data warehouse too, which is also now we are calling it lake house because we are now able to do asset property. We'll discuss this in detail. Once I stored my data, the next part is my data is processed, it is stored into a table, and next part is my Power BI job. Here, usually a REST API comes. So I just put a wait activity. So we need a Power BI uh, a premium subscription, which only companies have. Uh, so I just put a wait activity, and why we do that? We'll just refresh our data with so whenever we get some incremental data, we store into a table, and then we say that Power BI refresh the data in the backend of Power BI, and once the data is refreshed, we can create we can get the data in Power BI. It's very simple. You have to get the data, go on it, and you'll see a several connections from it. But you in you can either store in here. I just stored into a delta lake fold uh, delta table. We can store it to a SQL database or a warehouse, and then and from here we can just create a connection with the data. This I'll say Databricks, and I'll connect it with my database, and I can see my fire data set here. This is my fire data set, and then this is a now once the data is present in the serving layer, now there comes a job for a report developers who will develop this report, or BI developers who will develop this report. Um, in some companies, we do it's something we should know how to do it, uh, but if you don't know, that's not a negative point. So I'll just show you how a good power point presentation would look like. So this is one of the power presentation uh, we have shown. All right, that's it. We have I'll come back to our
Yeah, so
slides.
I think we
All
have
right.
few minutes left, right, Vikas?
All right.
so we can
What
wrap
are we
up.
going to discuss in our training? So we'll start off with Python first 2 weeks. Then we'll go on to the SQL, and I'll usually definitely every day I'll give you some tasks to work on, or I'll give you some industry which are generally asked questions. Um, and then in the next month we'll cover the Spark, what is Spark and how you can write a Spark queries. We'll discuss Spark architecture, lazy transformation and action, what is the lineage, and then we'll discuss more. We'll come to an Azure part of it, where we'll how to read the data from Azure Data Lake, how to read data from different sources, whether it's a CSV, JSON, or Parquet file. What is a Parquet file? What's a Key Vault storage account, where we store our data? Key Vault, where we manage our credentials. Databricks Delta, and then how to create a ETL pipeline. This is something it's good to have if you have the knowledge. One is Event Hub and Cosmos DB. So I'll just give an overview. We'll not go into detail. This is just a type of one of the type of storage. So Cosmos DB is one of the famous NoSQL database provided by Azure. I'll just give an overview of that. And Event Hub is something which is used for real-time system. I'll hand over the stage to Manjinder.
Okay, I'm on mute. So thank you. You can see my screen, right? I hope like you guys can see my screen. Uh, and okay, so as you know, like the data engineering, like this is a hot topic, and the demand of the data engineering is increasing, and we have designed this course in a way like you can get your training sessions and some
Hello.
practical sessions and with quizzes, and we will give you some home assignment, right? And there should be one teach back sessions. So the overall training pattern should be like we're gonna give you training, and we want like after this training you're gonna get a job somewhere. Like if you are coming from a like fresher background, or like if you are a professional and you want to switch your career and you are want to move into the data engineering side, and this course is like designed for you guys. We will give you the complete details. And just to overview of this program is like this is going to start on 19th of June, and the timing is 9:30 to 11 EST time zone, and 7 to 8:30 IST, Sunday and Saturday. So that's all from our side. So we will give you the details, the program, the training content, and the other details in the emails. And still, if you have any question and concern, like you can send us an email at the info.brainnyscott@gmail.com. That's all. And thank you. Thank you for